All right, so now let's attempt to make this a practical application. So what we're going to do is we are going to separate mixtures of ions by precipitation methods. So what we're going to be doing is sort of a qualitative analysis. We are going to be using experimental procedures to determine which ions or elements are present in a substance, or to separate out different ions or elements that are present. The key idea here is we are going to be looking for reagents that will react with one ion to form a precipitate, but not the others. So there's a couple ways they can word these questions. The first one I've got here is a solution which contains only one of the following anions, so bromine, sulfide, and hydroxide, is tested with various reagents and the following results are obtained. So when we mix these anions with these soluble substances, either a precipitate or no precipitate was formed. So you'll notice all of these are soluble substances. They're all mixed with nitrate. So when these mixtures were put in the presence with the ions, so they would bring this in as sodium bromide or sodium sulfide or sodium hydroxide, and you formed precipitates in these two scenarios, but not this one. And so then the question is, which substance is in your beaker? Okay, so what we're going to do is we're going to use our solubility table to determine what we think, or not what we think, what should happen when each of these anions are in the presence of these different cations that we're introducing. So I'm just going to grab my data package. Okay, and we're going to use our data package to determine what each of these cations should do with each of these anions. So I'm just going to split my screen because that's probably going to be easier for this. So I'm just going to go like this and like this. Okay, so let's look to see what each of these anions do with these different cations. So for example, if we are mixing things with bromide, so bromide is in this category. Bromide is soluble with everything but silver, lead, and copper. So bromide precipitates with lead, and not strontium and not barium. Okay, then let's just see what these three things do with sulfide. So in the presence of sulfide, it is soluble with strontium and barium, but it'll precipitate with everything else. So again, it precipitates with lead, but it is soluble with sulfide or with strontium and with barium. Okay, then let's look to see what happens with hydroxide. So with hydroxide, we have, here we go, it is soluble with strontium, but then it precipitates with everything else. So the question is, which of these anions is present if with strontium you don't precipitate and with lead and barium you do? So you'll notice the only anion that this could contain is hydroxide. It's the only anion that goes no precipitate and then precipitate. Okay, so that's kind of the foundation of what we're going to be doing. That's one of the things they can ask you. Another one is going to be something like a solution contains barium and lead. What compounds could be added and in what order to separate these ions? So what we're going to be looking for is different anions that will precipitate with one reagent at a time. So we're going to be looking at something that will precipitate the barium or the lead but not the barium, or the barium and not the lead. So what we like to do is the same thing I just did above, is use our solubility chart to guide our reaction. So we're just going to fill out this chart. So I'm just going to split my screen again. And what we're going to do is we're going to look with each of these different elements. So I'm just going to clear this so it's not dirty or like messy. So we're going to look at with chloride, bromide, and iodine. So with these three, it precipitates with lead but not barium. So I'm going to say precipitates but doesn't. With sulfate, it precipitates with lead and barium, so precipitates. For sulfide, it precipitates with everything but barium, but not lead, so lead is going to precipitate, but barium is not. And then we go to hydroxide. Hydroxide is soluble with strontium and then all the usual things, but precipitates with everything else. So it's going to precipitate with both of those. And then lastly, if we look at phosphate, carbonate, and sulfite, it is going to precipitate with everything. So now what we're going to do is we're going to use this chart to determine which anions will the lead precipitate with that the barium won't. And the answer is you could use chloride, bromide, iodine, or sulfide. So what we want to do is introduce one of these anions into solution to precipitate out the lead, leaving the barium in solution. So the first thing we want to do is precipitate the lead. So what are we going to add? Well, we're going to add sodium mixed with one of these anions. Now the easiest one is chloride, because obviously sodium chloride is salt. So let's add sodium chloride. So let's add aqueous sodium chloride. If we add aqueous sodium chloride, we are going to form lead nitrate, or lead chloride, sorry. That is going to be our solid that we are going to form. So the net ionic equation would be a lead aqueous plus a 2-chloride aqueous ions. So this is going to be our net ionic equation to precipitate the lead as lead chloride. So the lead chloride is the precipitate, and we're going to filter it off, because what we're trying to do is we are trying to separate the ions out of solution. So if we add the sodium chloride, the lead chloride will precipitate out, and then what will remain in our solution is still this barium ion. So if I now wanted to precipitate barium, what could I use? Well, I can use either sulfate, hydroxide, or phosphate, carbonate, or sulfite. And it's kind of your choice. Again, there's no wrong answer. So if we were in a class, I'd say choose one. If not, I get to choose one. So let's choose sulfate because it's written first. So let's add sodium sulfate as an aqueous solution, so that I will precipitate off the barium sulfate. Right? Barium's 2+, sulfate is 2-. So we're going to precipitate that off, and so we're going to have barium 2+ aqueous combining with the sulfate aqueous, so that the barium sulfate will be the precipitate, and we can then filter it off. So then we've separated out the ions. Just a tip, when you look in Hebden at these questions, you always need to filter the precipitate before adding the next reagent, because otherwise once I've created lead chloride, if I don't precipitate or if I don't filter it out, it's just going to sit in the bottom, and then the barium sulfate's going to sit on top, and then you're going to end up with a pile up. And so you just want to make sure you filter it off so that you can actually separate out the ions. Okay, so hopefully you're feeling kind of okay. It's kind of a weird process, but it's kind of like a puzzle, right? It's sort of like the missing steps in the reaction mechanisms, where you kind of either like it or you hate it. So with any of these questions, what you're doing is creating one of these solubility charts to look at how things will react, and then answering the question, either identifying an ion that's present in the solution, or maybe trying to separate ions in solution, or like we do in this third one. In this third one, you're given 3 solutions in separate beakers. You're told that one of them contains lead, one contains calcium, and one contains magnesium. Your job is to identify which is which using precipitation reactions, be specific about what compounds you add, and oftentimes they want to see the net ionic equation as well. So what are we doing here? Well, we have these 3 cations that we are going to add anions to and try to precipitate to identify which one's which. So let's make a little chart. So our chart is going to be lead, calcium, and magnesium. And then our anions are going to be. So if you don't have them memorized yet, which even I don't, right? I go to here, and what I do is I just pick one from the categories that have three. So for chloride, bromide, and iodide, I would just pick chloride. And then we've got sulfate. And then we've got sulfide. And then hydroxide. And then I'm just going to choose phosphate. Okay, so then I'm going to look to see how each of these react. So I'm going to start with the chloride. Chloride precipitates with lead, copper, and silver, so just with the lead. Then we look at the sulfate. And if you want to do this on your own, please feel free to pause the video. Okay, so then we're going to look at sulfate. So sulfate precipitates with silver, calcium, strontium, barium, and lead, but not with magnesium. Then we look at sulfide. Sulfide is soluble with magnesium, calcium, but not lead. Then we move on to our hydroxide. So it is soluble with strontium, which we don't have, and so it's going to precipitate with everything. And then lastly, our phosphate. Phosphate is going to precipitate with everything. All right, so now that we've completed that chart, now we have to figure out how we would identify each of the beakers. So looking at this, the first thing I would notice is that in this column, well, actually, I would say in this column, you precipitate with only the lead as well as in this one. So the safest thing to add would be either the chloride or the sulfide ion first, because then you're going to determine which contains lead, and then you can take that one out of the picture. So for me, the first thing that I'm going to do is I am going to add, let's go sodium chloride again. To precipitate the lead ion. So the precipitation is going to be that you are going to have the lead 2+, which is already floating around in solution, and when it meets the chloride, it's going to form lead chloride. Okay, perfect. So then we would remove that beaker. So now that we already know which one contains lead, now lead is out of the picture. Now what we're looking at is calcium and magnesium. So we're looking for something that precipitates with calcium and not magnesium, or with magnesium and not with calcium. And the only one that's going to do that is going to be the sulfate. So the next thing I would do is follow that same model. So number 2, I'm going to add sulfate. So to bring sulfate in, I'm going to add sodium sulfate, aqueous, to precipitate the calcium ions. So what's going to happen is the calcium and the sulfate is going to form calcium sulfate, solid. And then number 3, the last beaker with no precipitate contains my magnesium. Awesome. Now, if I wanted to make sure that it's actually present, then I could add sodium hydroxide, or I could add sodium phosphate to make sure it's actually there. But I'm going to assume that if they tell me for sure one of my beakers contains the lead, one of them contains calcium, then I'm going to assume that the third one is going to contain the magnesium. How's this feel? It's kind of weird, right? I find these kind of weird because we should actually make this as our lab in this unit. Identify which of the following. Okay, last one. You are given a solution containing silver ions, strontium ions, and magnesium ions. So again, a bunch of cations. And you must separate them one at a time from solution using precipitation reactions. To show how you would do this, write the net ionic equation for each precipitate form. So I've been leading you for that because that's the way that I did the one above, though it didn't ask for it. So the first thing we would do again is set up our solubility table. So this time we have silver, which is a 1+. We have strontium, which is what is strontium? I think it's 2+. Strontium, yeah, 2+. And we have magnesium, which is also 2+. Okay, and we are going to look to see how it reacts with all the different anions. So again, we're going to choose chloride. We're going to choose sulfate. We're going to choose sulfide. We're going to choose hydroxide. And lastly, we're going to choose phosphate. Or you could switch it up. Okay. All right, pause the video. Fill in this chart. Okay, and then I'm going to go through and do it too. So chloride precipitates with silver, lead, and copper. So precipitate, no, no. Sulfite is going to precipitate with silver, strontium, but not magnesium. Sulfide is going to precipitate with magnesium and strontium, but not silver. Hydroxide is going to be aqueous with strontium, but precipitate with the other two. And then phosphate is going to precipitate everything. Okay, then we have to figure out how can we isolate one of the species first. So the idea is you're going to look for the anion that precipitates with only one of the cations. So that's going to be chloride, right? Chloride precipitates out silver, but nothing else. Everything else precipitates out more than one species. So the first thing you're going to do, and follow that example that we've got above, or follow this example here, right? Add sodium chloride, net ionic equation. Blank is the precipitate, filter it off, and then figure out what's still remaining in solution. So let's add sodium chloride, aqueous. And so this is going to be silver. I wish I just didn't have to include the states. I feel like that would be easier. Plus the chloride would form the precipitate silver chloride, solid. Okay, and then I'm going to filter the silver chloride out. Left is going to be magnesium and strontium. Okay. So now we have to figure out how to separate those out. So the second thing we are going to do is now we can get rid of that silver row, right? So now I can go gone, 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 gone. We don't have to worry about it. So now we're going to look for something that precipitates the strontium but not the magnesium, or the magnesium and not the strontium. So you actually get a couple options here, right? We could go for the sulfate, because that would precipitate the strontium but not the magnesium, or we could go for hydroxide, which would precipitate the magnesium but not the strontium. So it's kind of your choice. What do you want to do? Right? So you guys can't talk back to me, so let's do sulfate. So let's add sodium sulfate. If we add sodium sulfate, what's going to happen is that that is going to have the strontium ions are going to combine with the sulfate ions to form strontium sulfate, solid. So then I'm going to filter off the strontium sulfate. And then I'm going to be left with, or remaining, is going to be the magnesium. Now, can we be done? It says you must separate them one at a time from solution. So we need to get that magnesium out. So the last thing we're going to do is try to precipitate out that magnesium. So now I can pick sulfide, hydroxide, or phosphate. So because hydroxide was the only one that precipitated just magnesium, let's use it. So let's add sodium hydroxide as an aqueous solution. And what it's going to do is it's going to have the magnesium 2+ aqueous combine with 2 hydroxide ions, you'll see why in a sec, to form magnesium 2+ hydroxide 1- solid. And then you're going to filter the magnesium hydroxide. Oh, my hand is cramping. This is a lot of writing. So, I don't know. Is this fun? Yes or no? It's not hard. I just find it a lot of writing. So the key thing is setting up your chart, and then it's process of elimination. Precipitate off one thing at a time. So either the beaker will contain something, or each of the beakers will contain different things, and you have to identify which beaker contains what, or the beaker will contain everything, and then you want to precipitate off one thing at a time to separate all the different ions. Whew, that was a long one. All right, good luck.